In this video, we're going to study the slopes of lines, whether we're given the graph of a line and asked to estimate its slope, or whether we're given two ordered pairs and we can use a formula given by y2 minus y1, and that's where we subtract the y coordinates of the 2 points given, divide that by the difference in the x coordinates. The main thing is to make sure you subtract in the same direction both times, and we're going to go over plenty of examples of this. Just as an estimator, you will have 4 different types of slope. If your slope of a line is 0, then that line will be horizontal. If the slope of your line is positive, then it will run up and right. The vertical change is positive, and your horizontal change is going to also be positive. When the slope is negative, the bottom left example, you're going to have a line whose orientation is down and right, meaning vertical change negative, horizontal change positive. And as a good rule of thumb, you'll always want to read these graphs from left to right, and then just let up or down be your decider if it's a positive slope or a negative slope. So again, your slope of a line is the vertical change over the horizontal change, and that's that little delta symbol, the triangle at the top right of the page. That delta just means change. And so whether you have a graph or not, you can still always find the slope of a line, whether you have the graph or just given a couple of points that it runs through. As a quick exercise, let's sketch the lines that pass through the point -1, 3. The first line we're going to sketch will have a positive slope of 1/4. The second line will have a negative slope of -2. First, let's plot -1, 3. So we're going to draw an x and y axes. Your x-axis runs horizontally, your y-axis runs vertically. The point -1, 3 from the origin is going to be left 1, up 3. Your x-coordinate is always the left or right movement. The y-coordinate is your up or down movement. So -1, 3 will be here. Okay, our first line we're asked to sketch has a positive 1/4 slope. From the point of interest, if you go up 1, let me change colors here. We'll do this one in blue. We go up 1, right 4, then this will be the stopping point, and I'm going to mark that as our first slope. So from the point labeled, if you move up 1, that's the vertical change, right 4, that's the horizontal change. When you connect these two dots, you will have the graph of that first described line. The second slope we're asked to use when we draw a new line, and I'm going to do it in red, is -2. Now since -2 is equal to -2 divided by 1, that gives us a horizontal change that we can count off. Going back to the graph, again from the point of interest, -1, 3, a negative slope we're going to count down and then right. So from here we count down 2 over 1. This is the location we're going to pass through. And so this line passes through that same point, but it is negatively sloped, specifically -2. Let's investigate 2 different ways to find the slope of a line if the graph is given. Your first technique is to basically try to count off a stair-step method. If you have 2 points labeled and you don't want to use the slope formula, that's okay, you don't have to. What I recommend is starting with the leftmost point out of the 2 you'll be given, and count off the stair step that it takes to get to the second point. Remember, you want to use vertical change over horizontal change to record your number. So we're going to have to go up 2 over 1, 2, 3. Up 2 over 3. Now you got to keep them straight on vertical and horizontal, but other than that, you're in good shape. So we're going to report the slope as positive 2/3. If you decide to employ the slope formula, then that's just a backup technique or another technique, depending on how you want to do it. We're going to take the second y, or the rightmost y coordinate, subtract the leftmost, divide that by the rightmost x minus the leftmost x. Our y coordinates of the 2 points given are 2 and 4. The high y, the one in the rightmost point, was 4. The y coordinate in the leftmost point was 2. For your x's, you have 0 and 3 from the points given, the rightmost x minus the leftmost x. And as expected, we get 2/3. And we're supposed to. So you can get your slope visually by counting, or you can go right to the formula and just force calculate it. Now, you're not always given the graph or 2 points that a line passes through. In a lot of your examples, you're going to have the equation of a line given. One format that you can look at is called slope-intercept form. Y equals mx plus b. M is the slope of your line, and B is the location where your line will cross the y-axis. So let's go back to our problem. We have y equals 3/2 x minus 3. Anytime you can get your equation to say y equals, the x term will contain your slope, and the constant will be your y-intercept. For this problem specifically, our slope is 3/2. And our y-intercept is -3. From the previous slide, we know how to put this information together. We can sketch our x and y axes. First, and this is the way you're going to want to do slope and intercept technique, is you want to count off your y-intercept first. So we're going to go down to -3, put a point, and then we're going to use the slope as a counting measure to get to a second location, place that dot, and then connect the dots. A positive 3/2 says that from the y-intercept, we're going to have to go up 3 over 2, which will take us to the point 2, 0. And then when we connect these two dots, whoops, I missed. We have successfully sketched our graph. So plot your y-intercept first, count off your slope, up 3 over 2, plant that second point, and then you'll have to connect those dots and you've got your line. On the very first slide, we looked at a couple of slope cases where the slope was 0. Let me change this to different ink. Here we go. where the slope was 0. And when that's the case, you have a horizontal line. Now keep in mind, these are a couple of special cases. The other one was when the slope was undefined. And the orientation of that line is vertical. And so I'm just going to put that one over here. With these two special cases, you have special equations. If your line is positively or negatively sloped, then your equation will contain both an x and a y variable. If your line falls into one of these two special categories, then let's suppose this crosses at 3. Then your equation for horizontal lines is only going to contain the y value at the intercept. And on this graph, let's suppose that crosses at -2. For a vertically oriented line, you will only have the x variable at whatever number the intercept is. So just be very cautious on these two special cases. If your equation only has a y or only has an x, it will fall into one of these two categories. And specifically, your equation will have the intercept as your numerical value. All right, let's go back to graphing using slope and intercept, the example we had on the previous slide. Maybe your equation's not given as friendly as it was in the last problem where we had y equals and that was slope-intercept form. Maybe your equation is not in that format. Maybe it's in this format, standard form. I'm going to show you a couple of different ways to graph this type of equation. The first way is an intercept method. If you let x be 0, 2 times 0 plus 3y equals 6 will give you a y value of 2. This tells us that the graph will cross at a point 0, 2. If we let y be 0, 2x plus 3 times 0 equals 6. That gives us 2x equals 6. So x value of 3. By letting each variable take a turn at being 0, you will have identified your x and y intercepts. You plot those 2 points, connect them with a dot, and there's your line. It's an easy sketch. The other way is like the technique we used from the previous slide. If we isolate y, so we're going to take off 2 x's, divide everything by 3, then that gives us y equals -2/3 x plus 2. I'm going to graph this on the next slide, but I also wanted to point out that either way you do this problem, the y-intercept is at 2. See how that matches up? And if you count down to and over 3, which is the slope, you will land at the point 3, 0. Let's go to the next slide and play that out. Okay, so we started with 2x plus 3y equals 6. From letting each letter take a turn at being 0, we found that when x was 0, y was 2, and when y was 0, x was 3. We also reduced our equation down to where y was isolated, and we found that to be negative 2/3 x plus 2. If you graph using slope-intercept, your first point, you're going to always want to lock in your y-intercept. So we're going to go in here and we're going to go up to 2. Let that be our first point. And from your y-intercept, that's where you want to count off your slope to get to point number 2. Okay, so what was our slope? Once y is isolated, it's the x term. Very good. So we're going to start here. We're going to count down 2 over 3. And sure enough, that takes us to the point 3, 0. So you can tell it's a pretty good, reliable method. You can do it either way. And we're going to connect the starting and the stopping point. Notice that our slope was a negative 2/3, and the orientation of this line is down and right. That should also be something in the back of your mind to let you know if you're on the right track. And let's finish this video with an example of a case where you just may be given 2 random points that a line passes through, and I'm going to make these points up randomly. Let's suppose we have negative 2 and 4. And maybe let's go with 1 and negative 5. Again, totally random. First thing we want to do is find the slope, and you be the judge on which technique you want to use. You can plot these 2 points, draw a line through them, and then count your stair step from the left dot to the right dot. Or from the very first slide, you can use the slope formula when you're given 2 points. We're going to do it both ways so that you can compare and contrast which technique you like better. If we go at it with the formula, we take the second y-coordinate minus the first y-coordinate over the second x-coordinate minus the first x-coordinate. Be aware that some of these you will have to subtract a negative, but just remember that's only addition. Negative 9 on top, 1 plus 2, that's 3. And then this divides out to an even, actually it's an odd number, but evenly divides to a negative 3. And that's our slope. That's one way to get your slope. Let's look at graphing and finding slope that way. And that way you've got options. Sometimes you learn better visually. Sometimes it's better just to use a brute force formula. If we graph the points negative 2, 4 and 1, negative 5, negative 2, 4, that's going to be left 2, up 4, right here. Left 2, up 4. The second point, 1, negative 5, from the origin, always start the origin, right 1, down 5, right 1, down 5. So we've got our points successfully plotted. Let's sketch a line through there. If we do, it's going to be a challenge. Here, I'm going to cheat and use a straight edge. There we go. All right, think about the orientation. This line goes down and right. So as it goes down and right, we know the slope has to be negative. We used the formula and we already got -3, so we kind of know ahead of time what the slope's going to be. But let's use vertical over horizontal changes. The vertical change I'm going to do in blue. This line travels a total distance of 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Down 9. How far over to the right does it go to reach that other dot? Starting here, 1, 2, 3, over 3. Down 9 over 3. Remember, slope is also defined as vertical change over horizontal change. Always count from left dot to right dot if you want to use this technique. -9 divided by 3 is -3, and lo and behold, we get a match. And we're supposed to. Each line has a unique slope. Slope is a numerical value to the direction and the steepness of your line.